Okay, lastly, we're just going to think about how we graph linear equations when we are given the equation in y equals mx plus b form. So y equals mx plus b form is slope-intercept form. So in this form, we are given our slope and we are given the y-intercept. So like I always do, we've got our list of steps and then we have a bunch of examples we can use in order to create our graphs. So my first step is to determine the scale of your graph and the relative quadrants and draw your graph. This might seem overwhelming, but all this means is, am I looking at just positive numbers? And if so, I really only have to draw this portion of my graph. I don't have to draw the entire thing. For example, if I'm talking about money made per hour, I'm not making negative money or working negative hours. So I would only have to draw a graph that looks like this. So for these first two examples, we're actually just not doing step one because that's adding another factor and I want to think about the basics first. My second step is to identify the y-intercept, so it's whatever number is not attached to the x, and plot it on the y-axis, which is our up and down. If we are still forgetting which one the y-axis is, remember my y-axis is just a y with a really long stem. So if that's how you can help remember, that's perfect. So let's do this first example. We're going to identify the y-intercept, which is the number not attached to the x, and we're going to plot it on our y-axis. So I'm going to find 1 and put a point. So I've done step number 2. My next step is to identify the slope and write it as a fraction and give the numerator the sign. So what I'm going to do is identify this slope. So my slope is -1/4. I'm going to write it as an up and down fraction so we can see it a little bit more clearly. And I'm going to give the numerator the sign. So the numerator is -1 and the denominator is 4. It's really important that we think of it this way so we don't end up drawing our slope the wrong direction. Step number 4 is to plot more points starting at the y-intercept and use the slope's numerator to tell us how much up if it's a positive number or down if it's a negative number, and the denominator tells us how many spaces to the right. So this is a really lengthy step, but hopefully this helps us create the correct graph. So I am going to just write it down next to my slope. So we said that the numerator tells us how much up or down. This is negative, so it's telling me to go 1 down, and the denominator is just how many units to the right. So I am going 4 units right. So these arrows are super helpful because that helps me visualize it a little bit more. So I'm going to go 1 down and then 1, 2, 3, 4 to the right, and I'm going to put a point. Notice that I didn't put a point right there because we had only done one of the 2 steps. You have to go down and then to the right. Once we have done at least 1 point, then we can connect our dots and extend our line in both directions. Oops, that was not good. Okay, try again. And like I've said before, if you don't have a ruler, you can use a folded sheet of paper as a ruler to have a straight edge, but it's super important to have a straight edge because otherwise you could intersect incorrect coordinates. So we did all of our steps. We graphed this equation. Wasn't so bad. Let's do another example. So my next example is y equals x minus 1. Like I said before, our first step is to determine the scale. I've already written the scale for you for these first two examples, just so we can focus on the other 4 steps at the beginning. So my second step is to identify the y-intercept. My y-intercept is my number not attached to the x. So looking at this equation, I can see that my y-intercept is -1. I am going to take this y-intercept and I'm going to plot it on my y-axis. So if I need to, I'm going to draw that y so I remember which one my y-axis is, and I'm going to plot a point at -1. My next step is to identify the slope and write it as a fraction and give the numerator the sign. So in this case, we could get stumped. This has no coefficient, or at least it doesn't look like there's one. But I need to remember, if there is nothing attached to my x, then there is an invisible coefficient of 1. So I know that this coefficient is 1. And there's no sign in front of it, so I know it's a positive 1. I also have to remember that when I'm given a whole number, there's an invisible denominator of 1. So I've got all these invisible numbers that I need to remember when I'm given an x without anything attached. So my slope, looking at this, is just 1, which means I'm going to go up 1 and right 1. So what I need to look at then is I am going to plot more points starting at the y-intercept and use the slope's numerator to go up or down and the denominator to tell me how much I'm going to the right. So this is positive, so I'm going up. I'm always going to the right with my denominator. So I go up 1, right 1, and I put a dot. Up 1, right 1. And then once I have a couple of dots plotted, I can connect them and extend it in both directions. And it's super important to extend it in both directions because that's what's going to allow us to see more of it. And we want to be very careful. We can see I kind of made a mistake because this should fall exactly on all these grid lines. So that's why it's super important to have a straight edge. So we've got our line. I'm going to white out this bottom portion. That is why I drew my arrow up here, because I messed it up a little bit. Let's go on to some examples that will not use the standard 4-quadrant graph that we count by ones with. So my first step is to determine the scale of your graph in its relative quadrants. So if I'm looking at this equation and I'm seeing that my equation has a y-intercept of -300, then I'm not going to want to count by ones because I'm not going to want to count all the way to 300. That would be extremely excessive and not even possible on regular graph paper. So what I need to think about is if I'm going to have a y-intercept that goes to -300, what should I count by on my y-axis to make that possible? So for me, I'm thinking 50s, because if I count by 50s, I have -50, -100, -150, -200, -250, and then -300. So that would fit my y-intercept. So that is what I'm going to count by. What I need to do is also create a scale for my my x-axis. So let me finish labeling this one. If my slope is 10, what I need to think about is what would that look like when I write out my fraction? So sometimes in order to figure out what our scale is, I should skip ahead to steps 2, 3, and 4 just to think about what I'm going to be counting by. So if my slope is 10, that means my slope is positive 10 over 1, which means I'm going up 10 for every 1 right. And I know that my y-intercept, we said, was negative 300. So what I'm going to do is think about, okay, I'm counting by 50s on this scale. So what would make sense to make a slope easy to look at? And this is just going to take a lot of practice. I know that what will make sense, since this is a ratio of 10 to 1, is a ratio that's the same. So I'm going to label this axis by 5s. So I labeled it by 5s, and you will see pretty soon why that is going to work for this specific equation being put into a graph. So step number 2, we said, was identify the y-intercept, which is negative 300. Once I've identified the y-intercept, I want to plot it on my graph. My third step is to identify the slope and write it as a fraction and give the numerator the sign. So I've already done that. My fourth step is to continue and add points according to my slope. So if I'm going 10 units up for every 1 unit right, that could be multiplied by 5 over 5, which isn't changing my fraction, but that'll help me work with the scale I have been given. So for every 50 units I go up, I'm going 5 units to the right. So that's just allowing us to make use of less space and to use this scale that we created to our advantage. More often than not, you will just be given the graph already. So it should feel easier because you won't have to come up with this off the top of your head like I did. You would be able to see a graph and figure out which scale represents your graph. Because I can check to make sure my slope is correct by saying, okay, this is an increase in 50 and then an increase in 5. So my vertical change is 50, my horizontal change is 5, and when that's simplified, that gives me my slope. Then we have another equation over here. So this equation says y equals negative 5x plus 55. So again, this one's gonna think about our first step in particular. That's a little bit different, is my starting point is 55. And in this scenario, this 55 represents how much money is in a lunch account. So we start with $55 and the person using the lunch account spends $5, I think it was, per week. So we're not going to have a negative number of weeks. So it wouldn't make sense to have a negative X value. So we're just focusing in on this first quadrant. We also want to think about scale. So like we did before, we can kind of skip ahead to the other steps to help us make our scale. So I can connect my dots and extend my line.